All right, but your answer does not have a decimal. Now, this is the first one that we can reduce. We can simplify this one. And we should. We should absolutely should. We just hadn't done that yet. Do you remember what numbers we try first to simplify? What is the very first number that you look for?
Can't remember.
Okay, so it's the prime numbers. It's the 2, the 3, the 5, and the so on. You could build a factor ladder, but you really just start like seeing what goes in to the numbers. And in this case, 2 does not work because it's odd and even. 3 does not work because the sum of the digits does not add up to a multiple of 3.
But 5 would work.
But 5 works. So you really you sit here and you got to divide both of these numbers by 5. Okay, now depending on your comfort level, you might remember that there are 5 20s in 100.
Yeah.
So that means in 300, I'm sorry, I wrote this backwards. There are 25s in 100. So that means in 300 there would be 60. And then in the 25 there's 5. Okay. These are just shortcuts to help you move through these problems a bit faster. Yeah. But then you try the number again and it does work again.
Okay.
65 divided by 5 is 13, 20 divided by 5 is 4. And this is your final answer.
Okay.
Okay, we're going to skip 4 for now and go to 5. That last one had a lot in it. So if it was 0.5, how would you write that as a fraction?
55 over 10.
Yeah, 5 over 10.
5
right?
over 10. Sorry.
But then with the 5, you put that.
55.
Yes. And then again, you got to reduce. You're going to divide both of these by 5.
Mm-hmm.
Okay, so we can do 4 next. All right, so we're going to look at the repeating part first. Okay.
Okay.
So what you do for the repeating part is you write it on top. And instead of that whole 1 and zeros, it actually goes over 9.
Okay.
All right. Now, similarly, because there's that 1 in front, that's going to go there.
Okay.
All right. But I mean, it raises the question like, well, what if it's like 0.27 repeating? Well, it would be 27 over 99.
Okay.
Actually, I'm sorry. Let me check this on the left here. Sorry, I'm not having lots of problems today. This is not correct. I apologize. Sorry, it's 1 and 3/9. Sorry.
Oh.
Sorry. So it doesn't go on the numerator. That's completely wrong. If you haven't seen me make a mistake, I make plenty of them. So, the fraction here, do you remember, you might have seen this in class. This is now a mixed number.
Yeah.
Do you remember how to convert those to an improper fraction, or maybe you can maybe just leave it like this? I'm not sure.
I should leave it like this. So
the question, now that I'm realizing this, that we might not have needed to do all this for the other ones, like 5.5. We could have done this. Let me reframe 5 here. Number 5 here. I'm always a little unsure until until I know what your teacher wants. We could have made this 5 and then done the 0.5 part as the 5 over 10 like this, and then reduce the 5 over 10 to 5 1/2.
Okay.
This is a mixed number.
Okay.
So that might be a question for your teacher, or maybe look at your notes. Let me know
Okay.
if you see anything.
And then we're gonna have to write each fraction or mixed number at the decimal in the next one.
Yes. Okay. So let's move to 6, 7, 8, and 9.
Okay.
And these you're not going to like, unfortunately. There's a couple of ways to do it. So sort of like the way that always works is to convert this to a division problem. 5 into 4.0. Okay, but there are other ways. And I don't know if your teacher did this. Do you remember from class what you did?
No.
Okay, so let's just assume it's this way. How
It
many
is
times?
that way, actually. Yes, it is
Okay,
that way.
how many times does 5 go into 4?
0 times.
0 times. But how many times does it go into 40?
Um,
5
8
times what number
8
gets you
times.
to, yes, 8 times. 8 times 5 is 40. Subtract, and you get 0.
Okay.
All right, so let's not do that one. I guess we do need a 7. There's a few nice ones that we could do first, but we'll just go right to 7. 7's the same deal here. The only thing I think that could be unclear is like remembering that the number on the bottom goes on the outside.
Yeah.
Because it almost never goes into the first number. Like 9 doesn't go into 1, so that's a 0. But does it go into 10?
Yeah. One time.
1 time. 1 times 9 is 9. You subtract and get 1. Bring down a 0.
10 again.
Okay, so it goes in 1 time. 1 times 9.
And subtract 1.
So there's a pattern.
Okay.
What is the pattern? What do you see as the pattern?
It's gonna keep repeating the 1.
Right. So it goes on forever. So you have to decide how to write this here, and you just count the numbers, the ones that repeat, or the digits that repeat.
Okay.
All right, so let's look at number 8. These aren't too bad. The mixed numbers, they're kind of distracting because the answer is going to be 1 point and then something.
Mm-hmm.
And that something comes from the decimal part. So you
Okay.
have to figure out, well, what is that something? But the one just comes with part of the answer.
Okay. Okay.
So 3 goes into 2 0 times, but it goes into 20 how many times?
Times.
6 times. 6 times 3 is 18. You subtract and get a 2.
2.
Bring down another 0. Looks familiar. That's 6.
Okay, so
18.
it's just gonna be repeating.
Right. So you look at this, you're like, all right, it's 0.6, or it's with repeating. That's the something. That's the, that's your answer. Your answer is 1.6 repeating.
Okay.
All right, so let's do number 9.
Okay.
Okay, so again, like the answer is 10 point something, and we get that from the division here.
Okay, so it'd be 10.6.
Exactly. And there are some shortcuts, once you get to know these. But all right. Okay, let's look at number 10.
Okay.
So you have a couple options here. You either convert them all to decimals or all to fractions. And you might think going to decimals is the best route. I would argue,
That's weird because I would pick fractions.
yeah, this one's 7/10, 1/4, and 3/5. And now you need to find the least common multiple of 4, 10, and 5. And sorry, I'm rushing through this. I do want to get as many as we can here. I do at some point have to stop. But the least common multiple is 20. So this is 5/20, 14/20, and 12/20. Okay, so when it says to order them from,
oh yeah, okay, you were about to answer. So never mind.
So when it says to order them from greatest to least, the answer is not these numbers, it's the original numbers. So you have to map them back. Like you have to map back that this is that one, and that's that one, and so on. So your answer is 0.7 is the greatest, comma, 3/5 is the next greatest, comma, 1/4 is the next greatest.
Okay, so
let's look at number 12 next, because it's very much like this one we just did.
okay.
So I would again convert everything to fractions, especially if 2 of them are fractions. So this last one is 49/100.
Okay.
And then you're trying to find the least common multiple between 10, 100, and 2, and it is 100. We would like to spend more time on this in a future lesson. So you got to figure out what goes in the top in each of these. So like the first one, you're going to multiply the top and bottom by 10. So that's 90.
Okay.
And then you multiply the top and bottom by 50 over here to get 50.
Okay. But
So
then ordering it from least to greatest, the greatest one is 1/2.
Greatest. You got to do the greatest one. So this one's the greatest.
Yeah. Oh.
It said greatest. Said greatest to least. I don't know. That's the teacher chose that wording. Usually it's the other way. Whatever. 1/2 and then 0.449. Okay. So let's really quickly do 11. So this one, when they're 2 decimals, you're gonna convert the last one into decimals. So 8 into 1 becomes 125, like that, 0.125. So you're looking at 0.25, 0.125, and 0.3.
Okay.
So then you just order them. You're like, oh, the greatest one is 0.3. The next greatest is the 0.25, and then 1/8.
Okay.
For 13 and 14, this will be probably the last thing that we can talk about here, is you want to convert them into the same thing, either both fractions or both decimals.
Okay.
All right. So like, for example, I don't know. Yeah, I'll just write that here. You just have to choose. Maybe you already know.
Okay.
But both fractions or both decimals, either one. You have to combine like things.
Okay. And then, okay. So then for 13,
you need to do the long division, and you'll find, I think that, let me just do that really quickly here another way. So it ends up being, it's so what it's what the for number 15, what 7 over 18 ends up being is 0.3888888. So the repeating part is just the 8.
Okay. Okay, but then for
Alright.
13 and 14, 13's equal, right?
Yes.